Alright, number 12 wants us to use a quadratic formula, and it says submit your answer as reduced fraction to lowest term, or round your answer to 2 decimal places. So this time you can put it as a decimal to 2 decimal places. Now, I'm not sure why they say use the quadratic formula, because you can solve it with just basic factoring, but I'll try to show you both ways. So the easier method would just be to factor this. This is 3x squared minus 5x equals 0. I would simply factor out an x from both terms, and then that will leave you with 3x minus 5. Let me pull an x from both terms, equal to 0. And then you set both of those equal to 0, so you would get x equals 0 is one answer, and then you have 3x minus 5 equals 0. Add 5, so you get 3x equals 5, and then divide by 3, so you get x equals 5 divided by 3. And if you were to convert that to decimal form, that would give you 1.6 repeating, or you can round it to 6/7. So 5 over 3 or 1.67 when you round it. So let's see if they will take it. It says you can round it to 2 decimal places. So I'm going to put in 0 and 1.67. Now, that is the factoring method. Quadratic formula. You need to memorize this formula. I think your textbook shows the proof of it, and I may actually do a video of it because I like it now that I understand it a little bit better. But it's ax squared plus bx plus c. This is the standard form of a quadratic equation. The quadratic formula is x equals negative b plus or minus square root b squared minus 4a times c, all divided by 2a. This comes from starting with this, doing that, completing the square, and you end up with this. It works every time. So you have to identify a, b, and c from your problem. A is 3, b is negative 5, c is 0, so there's no term. So b, negative 5, you plug it into a negative b, that gives you a positive 5, plus or minus. So you just do the opposite of b. Some people just say opposite b. Square root of b squared, so negative 5 squared, minus 4 times a, which is 3, times c, which there's no c, so it'll be 0, all over 2 times a, which is 3. Alright, and so you can already see this is a longer process than what we did here. So we have x equals 5 plus or minus square root. This is 25. When you multiply all this together times 0, just 0. So 25 minus 0 is 25, all divided by 6. And then we have x equals 5 plus or minus the square root of 25 is 5, all divided by 6. So we got two scenarios. We got 5 plus 5 over 6. And then we have 5 minus 5 over 6. This gives us 10 over 6. Reduce that to 5 over 3, which is that. And then this gives us 0 over 6, which is equal to 0. So 0 and 5 over 3, or as a decimal, we get the same thing. Alright, number 13. Use all my space. Number 13. Solve using quadratic. We're going to simplify to lowest term. 13. We have 5y squared plus y equals 3y minus 3. Alright, we're going to move everything to one side, so I'm going to subtract 3y, and I'm also going to add 3 over here. Alright, so the 3y, 0, that goes to 0, so on the right side we have 0. Over here, 5y squared plus, no, minus 2y plus 3. So now this is in standard form. We're going to do quadratic formula. Alright, so opposite of b, so this is a, b, c. So opposite of b, so opposite of negative 2 is going to be 2 plus or minus the square root negative 2 squared minus 4 times a, which is 5, times c, which is 3, all over 2 times a, which is 5. I'm going to simplify this. 4, that's 20 times 3 is 60, and then negative 60. So we have 2 plus or minus square root of 4 minus 60, all divided by 10. Negative under square root means we're going to have imaginary. So when I do 4 minus 60, this gives me 2 plus or minus the square root of negative 56 over 10. And then we're going to reduce this radical. I'm going to do that off to the side. Knowing that it's negative, I'm going to put imaginary. 56. 8 times 7, and then 2 times 4, and then 2 times 2. So we've got a pair of 2's. 2 and a 7 will stay together and give us 14. So we have 2 here, plus or minus. This turns into, a 2 comes out, and the I is there, 2i. And then the 2 and the 7 stay, you multiply that back together, and that gives you 14. So 2i square root of 14 over 10. All of these are divisible by 2. So we can divide by 2, not under the square root. So that will be 1 plus or minus I square root of 14 over 5. And from here, we'll just write them separately. 1 plus imaginary 14 divided by 5, and then 1 minus imaginary square root of 14 over 5.